In this video, we'll talk about and use the idea of finding the derivative of the inverse sine functions. So our general tactic here for finding derivatives of inverse trig functions is the same as it was before for general inverse functions. You can either use this formula, just what it looks like, or you can work it out by hand. I would encourage working it out by hand. It's what I'm going to do here. So I'm going to find the derivative of y equals inverse sine of x. Well, how can I do this? I don't know how to differentiate inverse sine, but I can differentiate sine. So let's convert this to a formula involving sine. So I get sine of y equals x. And then I can use implicit differentiation to find the derivative here. And if I do that, the derivative of sine is cosine. So I will get cosine of y times dy dx equals 1. And so dy dx, the thing I want to find, is 1 over cosine of y, or plugging in y, 1 over cosine of sine inverse of x. Now this is, I guess, technically correct, but it's not a great formula. It doesn't give me a good idea of how to actually handle this function. I want to figure out if I can write that in a way that does not involve trig and inverse trig functions. And the way to do that is by drawing a triangle. Now, how do I want to set up this triangle? Well, my formula above told me that sine of y equals x. So that means y is an angle and x is a side length. That means I can put, if I say y is going to be this side, if I want the sine to be x, it needs to be x over 1, so I can put x opposite and 1 hypotenuse. That will give me that sine of y equals x. Now, I need to find cosine of y. So for cosine, I need the third side, and the third side here then, by Pythagorean theorem, is 1 minus x squared. And I can now put that in here to get that this should be dy dx is 1 over square root of 1 minus x squared. The function y equals sine inverse of x. You could also, so maybe like this cosine, because cosine is root 1 minus sine squared, and use that to get there, but this triangle way works even better for seeing how to simplify this out to get to what this formula should look like. So for inverse sine, the derivative that I get is 1 over root 1 minus x squared. So just like all of our other rules, we can use product rule, chain rule, quotient rule, all of those with this formula. There's our example, we want to find the derivative of sine inverse of x squared. This is the chain rule because I have my sine inverse on the outside and the x squared on the inside. So I make that function u the x squared. Then my derivative here will be sine inverse, which is 1 over root 1 minus u squared, times derivative inside, which is 2x. And I plug in u being x squared. Giving this derivative should be 1 over root 1 minus x to the fourth, and the top is actually a 2x. And that's what you get for the derivative of the inverse sine of x squared. And you can think of a bunch of other problems where this would work the same sort of way. So that's the idea of how you'd find this derivative for inverse sine, and then how you use it to compute more complicated functions that involve the derivative of inverse sine.